Why did snakes get rid of their feet? A new fossil may help us figure it out. Now, it's really hard to say why something in the past happened, so evolutionary biologists tend to stay away from why questions and use questions more like, what was this an adaptation for? Or what did a structure or body plan allow an organism to do that its ancestors could not? We may think about birds, why did birds evolve wings? Well, to fly, of course, but if you look at the fossils of the earliest wings, they could not have supported the weight of the organism. They may have evolved to be for mating displays. It's unclear. So we focus instead of on the whys, on adaptations. And in the case of snakes, we're trying to figure out what an elongate, tube-like, limbless body plan would be good for. There are two competing hypotheses. One is the marine or swimming hypothesis. Now, the ancestor of all snakes was probably just a normal lizard, a four-footed guy, kind of short. And the idea is that this lizard went into the water and undulated its body. Now, if you've seen videos of monitor lizards or alligators swimming, they undulate their body and they don't really use their limbs. They keep their limbs tucked in at their sides, using their tail and their body to move themselves forward. Then, after generations of swimming and not really using their arms or legs, it became advantageous to not have legs. And so individuals were born without them, and they survived better than the ones that did. And then the whole species and the whole lineage lost their legs. The other hypothesis is the burrowing hypothesis. For this, it's really good to be underground. It's nice and safe. It's easy to thermoregulate. There's a lot of advantages to living underground. But it's a tight squeeze, so it's easiest to burrow if you are yourself tube-shaped. So they just tucked in their arms and then eventually they evolved away. Now, this has been really hard to figure out because the fossil record for snakes is garbage. Now, most of our earliest snake fossils, including some that still have back feet, are from marine sediments, which means the ocean. That means they were swimming. There was one early burrowing snake found, but hey, maybe that was a one-off. Well, now we know it's not. We found another burrowing snake. This is Tametera mirim, who lived in Brazil about 80 million years ago. This isn't the earliest snake fossil, but it is possibly the earliest diverging snake that we have so far. This means that the lineage that led to this snake split off earlier than other groups. That means it might be similar to its common ancestor with other snakes. This specimen is also special because it has a skull and it's preserved in 3D, which means we can tell what its brain was like. These researchers took a digital cast of the inside of its head to figure out what its brain shape was like and then compared it with modern lizards and a bunch of other snakes. And they found that the shape of the brain is most similar to lizards and snakes that are burrowing. It's actually most similar to this guy, which basically lives like a worm. This means that Tametera was probably a burrower. Does this mean that the earliest snakes were also burrowers? Not necessarily. Snakes probably evolved about 200 million years ago, and this guy lived 80 million years ago. So there's a huge evolutionary time gap there. Anything could have happened. But this does mean that by the time of Tyrannosaurus, snakes were already very diverse. Does this answer our question about why snakes evolved? Not really, though I'm personally on Team Burrower. But it does tell us that then and now, snakes do a surprising amount with a very simple body plan.